All right, let's get right into it. We are talking about a technology that is so incredibly precise, so powerful, that it literally promises to make the physical world transparent. This is all about quantum sensing, and yeah, it could very well mean the end of hiding as we know it.
So let's kick things off with a statement that sounds, well, almost crazy. For decades, right, GPS has been the backbone of everything. It guides our cars, it guides our most advanced military gear. The very idea that it's outdated seems ridiculous. But here's the thing. The system has a huge critical flaw. It can be jammed, it can be spoofed, and you better believe that in any real conflict, it would be one of the very first things to go dark. So if GPS is out, what comes next? Well, just try to imagine this. A sensor that could literally peer through solid rock, mapping out hidden underground bunkers from kilometers up in the sky. Or how about this? Imagine a technology that can track the most sophisticated, ultra-quiet submarines hiding deep beneath the ocean's surface, pretty much as if the water just wasn't there.
Look, this isn't some far-off science fiction. This is the very real promise of quantum sensing. And the bottom line, the core implication of all this, is that the fundamental idea of hiding, of concealment, is about to change forever.
All right, so let's start with the most immediate use case, the one that is already driving a brand new global arms race. We're talking about navigation, but navigation with absolutely no limits.
So what you're seeing here is this incredible contrast, right? On one side, you've got our whole modern world totally and completely dependent on these really vulnerable satellites. But on the other side, you have a completely self-contained system, a quantum navigation device. It doesn't need to talk to anything. That means it's unjammable. And get this, it can maintain centimeter-level accuracy for months on end, all without a single peep from an external signal.
And what's really cool is that this new method is basically perfecting a super old idea called dead reckoning. This is what sailors used for centuries. You start at a known point and calculate where you are based on your speed and direction. But the classic problem was always something called drift. See, tiny little errors in your sensors would just add up, and after a few days without seeing a landmark or getting a GPS ping, you could be miles off course. Quantum sensors, they pretty much eliminate that drift entirely.
Okay, so this begs the big question, right? How in the world is any of this even possible? How can a sensor be that accurate? Well, the answer is, you have to listen to the universe on its quietest, most fundamental level.
Think about it like this. A normal, classical sensor, it's like trying to hear a single whisper in the middle of a packed, roaring stadium. All that random shouting, what scientists call thermal noise, it just drowns everything out. A quantum sensor, though, is totally different. It's like it goes into a perfectly silent, soundproofed room and listens to the whisper of a single atom. At that level, the signal is absolutely pure. And the measurement you can get, it's nearly perfect.
And this is where we get into the quantum weirdness that makes it all work. Scientists are harnessing these really bizarre properties of the universe. You've got superposition, where an atom can actually be in two states at the same time, which makes it incredibly sensitive to the tiniest little push from gravity or motion. Then there's entanglement, linking particles so they mirror each other instantly no matter how far apart they are. This allows for even more precision, and finally, they can treat atoms like waves to measure movement with a kind of accuracy that classical physics just, well, it can't even come close.
So you can see how this all starts to stack up, because once you can measure gravity and motion with that kind of insane precision, you can do a lot more than just navigate. You can start to see things that are meant to be invisible.
And to really grasp the huge geopolitical stakes here, we have to talk about this one key concept: second strike capability. Look, for more than half a century, the fragile nuclear peace has been kept because of one simple fact. Even if a country launched a surprise nuclear attack, their enemies' hidden submarines would survive and be able to retaliate with devastating force. In that world, hiding is everything. But here's the game changer. A quantum sensor doesn't need to see a submarine with sonar, it just needs to feel it. It detects what's called a mass anomaly. Think about it, a giant metal submarine displaces a massive amount of water. That creates this tiny, localized change in the gravitational field, a change these sensors can pick up from far, far away. So this leads to a pretty terrifyingly simple question, doesn't it? What happens to global stability when the oceans effectively become transparent?
But, and this is so important, it's not all doom and gloom. It's absolutely crucial to understand that this same terrifying precision also has the potential to revolutionize our world for the better in ways that are just as profound, if not more so.
I mean, we're talking about wearable brain scanners that can map your neural activity in real time.
Imagine spotting diseases like Alzheimer's years earlier than we can now, or creating these incredibly detailed gravity maps of the Earth to find new mineral deposits without having to do any destructive drilling. You could have sensors monitoring the structural integrity of a bridge, atom by atom, or you could spot a tiny methane leak from a pipeline from miles away. The potential here is it's enormous.
Okay, so if this tech is so amazing, so revolutionary, why isn't it everywhere already? The short answer? Harnessing the quantum world is, without a doubt, one of the single greatest engineering challenges humanity has ever faced.
The first huge problem is temperature. These quantum states that make the sensors work, they are unbelievably fragile. To keep them stable and doing their thing, you have to cool them down. And I mean really cool them down, to temperatures colder than the vacuum of deep space.
Yeah, we're talking about just tiny fractions of a degree above absolute zero. Now imagine trying to shrink the massive room-sized refrigerators you need to do that down to the size of a chip that you can put in your phone. It's a truly monumental task.
And this second massive problem is noise, or what physicists call decoherence. It makes sense, right? When your sensor is sensitive enough to feel the gravity of a submarine a mile away, it's also sensitive enough to be totally thrown off by the vibration of a passing truck, or even a solar flare from millions of miles away. So figuring out how to shield these incredibly delicate devices from all the chaos of our everyday world, that is basically the holy grail of quantum engineering.
Which really brings us to the final and, maybe the most important idea of all. As we start to overcome these massive hurdles, we need to realize we're not just building a new tool, we are fundamentally building a new way of seeing the world itself.
And there's this quote from the source material that I think just captures this perfectly. You have to remember, for all of human history, we have lived in a world of approximations. Our maps, our measurements, our basic understanding of the physical world, it's all been based on estimates, on close enough. Quantum sensing, it changes all of that. It allows us to measure the fundamental constants of the universe directly. We are moving out of an era of guesswork and into an era of near certainty.
And so that leaves us with one final, and I think unavoidable question. This technology is going to give us the power to strip away all the veils, from the deep ocean, from the earth beneath our very feet, and maybe even from the inner workings of our own minds. So in a world where there are no more physical secrets, the only real choice left is what will we, as a society, decide to look at.